the x and the y-intercept and the slope, which we know because it's in the model. And all I wanted next is to click the right arrow, please. And this is it. Now, let's click the right arrow again and look at the residuals. No pattern whatsoever. This is 0, right? And the residuals are all over the place. There is no pattern, which tells us that the model, the linear regression, is okay for this data set. Okay? So going back, you have the actual data set with the fitted line, with the least squares regression line, the line of best fit that has the least error. It's the least distance from each point. So this is the error, or the residual, that is plotted on the next graph away from 0. Okay, any questions on this, or is this enough? Is it good? Are we okay with this? Where's my, here it is. Okay, so we are finished with chapter 4. We will start now chapter 5, probability. Any questions for me? And I am on page 4, I think. Okay, chapter 5. Probability. We have chapter 5 and chapter 6, and then we'll review for our test, which will take place on the 21st. So we have to move it to Wednesday, the 21st. That's our midterm. Okay, so let's start with what probability represents. So probability is the chance of something to happen, an outcome to happen. So probability, the chance of occurrence of an outcome. What is an outcome? Well, let's say an outcome. I flip a coin, and it has two possibilities of head or tail. And once I flip a coin, let's say I get a head, or I get heads, right? So this is an outcome. What will be the probability of this outcome? So I'm going to call this outcome A. What is the probability of A? Well, there are only two options. They're equally likely. So the probability will be 50%. 50% or 0.5. What if I want to flip again, and I'm looking for the probability of getting tails? The probability of getting tails is still 0.5 or 50%. Now, what is the difference between outcome and event? An event may have one outcome, two outcomes, three outcomes, and so on and so forth. Now, what is a sample space? And we're going to illustrate all these with example 1. Sample space refers to a probability experiment. Refers to a probability experiment. And it represents all possible outcomes. of that experiment. Okay, so then here's an example. Example 1. A probability experiment consists of rolling a single six-sided fair die. A fair die is one in which each possible outcome is equally likely. So we have a die. We're rolling the die. What can happen? We can get a 1, we can get a 2, we can get a 3, we can get a 4, we can get a 5, and we can get a 6. Identify the outcomes. These are possible outcomes. All possible outcomes. I roll a die, I can have 1, 2, 3, 4, 5 facing up, or 6. Now, what is a sample space? S sample space is listing all of them with braces like a set 1, 2, 3, 4, 5, or 6. Nothing else can happen. These are all possible outcomes. An event, roll an even number. Let's call it A. You can call it E for event, it's up to you. The same thing. So rolling an even number could be 2, could be 4, could be 6. So this particular event that has 3 possible outcomes. So from the sample space, I can only select an even number, 2, 4, 6. There are 3 possible outcomes. One quick question here is, or discussion about the complement of an event. So A complement, for this situation, I'm still talking about the event A from here. The complement will be anything else. What do I mean by anything else? 1, 3, and 5. That's the anything else. So the probability of anything else will be total probability of the sample space, and we'll talk about it in a moment, minus the probability of event A. Now we have to talk about what is the total probability, and I'll come back to this because it's a very important example or situation that we have to think of. Okay. So what are the rules of probability? The rules of probability are, number 1, and I have them listed up here at the top of page 4. So the probability of the sample space, everything that can happen, must be 1. Number 2, the probability of any outcome or event, you name it, has to be a number between 0 and 1. It cannot be a negative number. It cannot be 1.1. Number 3, the probability of an impossible event must be 0. And the probability of a sure, certain event must be 1. So now I'm ready to go back and finish up that the probability of the complement of an event obviously must be 1 minus the probability of that event. have example 2 ready for us. They're giving us a data set. We're talking about chocolate candies, M&Ms. I guess everyone loves those. Different color and different probability. The question is, the table shows each color and the probability of drawing that color. So they're all in a bag and we want to pull different M&Ms. Verify that this is a probability model. So if a data set like this one, if the information that we just got does not fulfill these conditions, it will not be a probability model. So this is a probability model. If all probabilities of all possible outcomes do not add up to 1, if the probabilities are not between 0 and 1 and the impossible 0 and the sure 1, then that's not a probability model. So first of all, I have to make sure that the probability for each is a number between 0 and 1. Check. Yes, it is a number between 0 and 1. The next thing I have to check is that that all these add up to 1. If they don't add up to 1, I'll say it's not a probability model. It's anything else but not a probability model. So where's my calculator here? So I have 0.12. I add to 0.15. I add to 0.12 again. I add to 0.23. Again 0.23. And I add to 0.15. And if the answer is not 1, I will say it's not a probability model. But it turned out that they add up to 1. And they are all positive between 0 and 1. We already talked about the probability of an outcome or event. We already talked about the probability of a complement of an event already. So let's talk about the law of large numbers. The law of large numbers really states, law of large numbers, states that if we repeat an experiment, a probability experiment, if we repeat a probability experiment a large number of times, the probability, the proportion with which a certain outcome is observed gets closer to the probability of the outcome. So the proportion, in other words, we will get to the probability of what we're looking for. If we repeat the experiment many, many times, it's almost certain that we will get to the probability of that outcome. So the proportion with which an event or an outcome is observed gets closer to the probability of the outcome. I'm going to write it like this. Okay, we are on page 5. We have two different ways of determining probabilities. Ways of determining probabilities. Two ways of calculating probabilities. Here's number 1. Using the empirical method. What I like to call this is frequency method. What does it mean? I observe, I perform the experiment. So here's an example. This is a game that I know nothing about. It intrigued me and I didn't look it up. But I will, to see what this is all about. But I'm assuming it's something like the situation with the die, roll a die. So we are building a probability model using this game. it says it's a Milton-Bradley game. I said again, my apologies, I don't have any knowledge about the game, but that's okay.